Imagine this, a guy are pushing a car but from the opposite sides there is a man stopping the car from moving. One's pushing from the left, and the other's pushing from the right. Now, what happens? Will the car move, stay still, or something else entirely? What force actually moves the car? Well, let's find out by diving into the fascinating world of resultant force. Resultant force is the single force that represents the combined effect of all the forces acting on an object. It's like a superhero team-up, just like how two forces can work together or against each other, the resultant force is the final force that shows the true effect. So, let's get started and see how this works. First, let's look at forces pushing in the same direction. Imagine two people pushing a car from the same side. One's applying 10 newtons, and the other's pushing with 15 newtons. What happens? When forces push in the same direction, all we have to do is add them up. So, in this case, 10 newtons plus 15 newtons gives us a total of 25 newtons of force. Easy, right? The car will move with that total force in the same direction. Now, let's take a twist. What if the forces are acting in opposite directions? Imagine our two people again. But now they're pulling the car in different directions. One person is pulling 20 newtons to the left, and the other is pulling 15 newtons to the right. What happens then? When forces pull in opposite directions, we subtract them to find the resultant force. So, 20 newtons minus 15 newtons gives us a resultant force of 5 newtons to the left. The car doesn't stand still, it moves to the left because that's the direction of the greater force. Alright, let's take it up a notch. What happens when forces are acting at angles? Imagine one person pushing the car to the right with 10 newtons, and another person pushing it upwards with 10 newtons. Now they're at right angles to each other. When forces act at angles, we can use Pythagoras' theorem to find the total force. So, to calculate the resultant force, we take the square of both forces, add them together, and then take the square root. For our case, the forces are 10N and 10N. Applying the theorem, we get a resultant force of about 14.14 newtons in the diagonal direction. Now that we've seen how forces combine in different scenarios, let's take a deeper dive into the science behind resultant force. Forces are vectors, which means they have both magnitude, which is the strength of the force, and direction, which is where the force is acting. To help visualize it, imagine you're pushing a box across the floor. You apply a force in one direction, but the box is also being affected by other forces, like friction, gravity, or maybe even a friend helping you. Each of those forces has a direction and strength. Now, let's break it down. Forces in the same direction. When forces act in the same direction, we just add them together. Think of it like a tug-of-war game. If two people are pulling the rope in the same direction with equal strength, the rope moves with the total force of both. So, the bigger the combined force, the greater the movement. Forces in opposite directions. But what happens when forces are pulling in opposite directions? Well, that's like a tug-of-war game where one person pulls the rope to the left and another person pulls to the right. The force that is stronger wins, but the movement is reduced by the smaller force. To find the final direction of movement, we subtract the smaller force from the larger one. Forces at angles. When forces act at angles to each other, the situation gets a little trickier. It's no longer just a straight line. Forces pushing in different directions form a kind of triangle. And to find the resultant force, we use some geometry. The method we often use is called the Pythagorean theorem, which is a way of solving right-angled triangles. Here's how it works. If you have one force acting to the right, let's say 10 newtons, and another acting upwards, also 10 newtons, we can calculate the resultant force by creating a right triangle. The hypotenuse of that triangle gives us the resultant force. And with a little math, square the forces, add them together, and take the square root. We can find out how much force is acting in the diagonal direction. For this example, the resultant force is about 14.14 newtons, diagonal. and combining the effects of both forces. Whether forces are working together, opposing each other, or acting at angles, the key is to break it down into manageable parts. And it's all about finding that one resultant force that describes the combined effect of everything acting on an object. Well, this principle helps us understand everything. From why a car moves when you push it, to how we calculate the forces on an airplane wing, or even how we design safe buildings and bridges that can withstand strong winds and earthquakes. Knowing how forces interact and how to calculate resultant forces is a fundamental skill in physics, engineering, and even sports science. So, in short, understanding resultant forces is like solving a puzzle, where every piece, or force, needs to be carefully placed to create the right solution for movement or stability. So, that's the lowdown on resultant force. Whether you're pushing a car, pulling a rope, or even playing a game of tug-of-war, forces are always at play. They can work together to move something, or they can cancel each other out to keep things still. But, as we've seen, there's no magic involved. Just a little math and some basic physics. Now, next time you're out there trying to get your car to start, or moving a massive pile of laundry, just remember, if you're pushing it the same way, you just add the forces. If you're pulling in different directions, you subtract. And if you're at an angle, well, it's time for some Pythagorean wizardry. And hey, always remember, when forces don't seem to add up in your favor, maybe it's time to rethink the direction of your push. Or, in my case, just blame the wind. Science is here to explain it all. So the next time you're in the middle of some heavy lifting, or even just trying to move your furniture around, take a second to think, what's the resultant force? Is it helping me move? Or is it stopping me from doing something silly, like accidentally pushing the couch into the wall? Trust me, you'll be thinking physics in no time.